Hi, in this video I'm going to show you some examples of how we can use Pascal's triangle or the binomial theorem. Now let's start with a very basic expression. Suppose I want to expand x plus 2 to the fourth. Now there are many options that you can do when the expression is still simple and the exponent is not yet big. Like, we could think of x plus 2 to the fourth as x plus 2 times x plus 2, then x plus 2, then x plus 2, then just multiply, like work on this first 2, then work on this first 2, then multiply them eventually, and you can get the expansion of x plus 2 to the 4. So that's method number 1. Method number 2 is make use of the Pascal's triangle. Now take note, this is just 4, so it's easy to recreate the triangle. So like 1 1 1 1 2 1 1 3 3 1, okay, and then the 4. So for the 4 we have 1 4 6 4 1. Okay, so in order for you not to be confused with the triangle, so this exponent should appear. Okay, so 1 4 6 4 1. So to expand x plus 2 to the fourth, then we have, so x plus 2 to the 4, I should have 1 4 6 4, and then we have the 1. Okay, and for the Pascal's triangles, a more systematic way of doing this is, so I have x to the 4, and then x to the cube, x squared, x and no x. Then for the 2, so no 2, 2 to the 1, 2 to the 2, 2 to the 3, and then you have 2 to the 4. Okay, that's our pattern. So all these are positive. Okay, and then after that, just simplify. 1x to the 4 becomes x to the 4, and then you have 4 and 2, so that's 8x cubed, and then 6 times 4, 2 squared is 4, 24x squared, 2 cubed is 8 times 4, 32x, and then this is 1 times 2 to the 4, 2 to the 4 16, so times 1 is 16. So this is the expanded form, okay, using the Pascal's triangle. Now, if you want to use the binomial theorem, the only difference of the binomial theorem and the Pascal's triangle is that instead of creating this triangle, you have to make use of the combination formula. So we have a 4 0, and then 4 1, 4 2, 4 3, until you get 4 4, and it will be the same thing. You work with x to the 4, x cubed, x squared, x and no x, same idea. So the only difference is on how you get these numbers. Okay, and then basically the next steps will be the same. So those are the 3 options that you can do. So if you can expand it easily, so you can use the first method. So this is the first method, expand. You can do that. Second method, use the Pascal's triangle. And the third one is you have to make use of the combination formula, which is very similar to method number 2. Okay, so that's how you expand simple binomials. Okay, let's look at more complex examples. Not really that complex, but let's put some negative signs. Okay, so suppose I have like 3 minus 2x to the 5th. So 5 is not yet a big number. So maybe we can proceed with the Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You see? So that's a 5. Okay, so you end at 5. So 3 minus 2x, so I have to place these numbers. So I have 1, I have 5, I have 10, 10, 5, and 1. Okay? Now to place your first term and the second term, a more convenient way of doing this is to rewrite it into 3 plus. Then you have negative 2x. So this is raised to the 5th. So I just changed the minus sign into a plus and the negative. Okay, so in that way, it will be easy for me to place the first term and the second term in the expansion. So the pattern is you start with 3 raised to 5, 3 raised to 4. So the exponent is decreasing. 3 raised to 3, 3 raised to 2, 3 raised to 1, and then 3 raised to 0 or no 3. And then for the second term, you have negative 2x. So that's actually to the 0, so there's no need for negative 2x on the first. And then you have negative 2x to the 1, negative 2x to the 2, negative 2x to the 3, negative 2x to the 4, and negative 2x to the 5. Okay, so this should be your expansion. So let's look at it. Okay, the good thing about rewriting this with a plus and negative is that you will not forget the signs for the negative terms. Okay, it's because they will automatically appear. Unlike if you stick with 3 minus 2x and then memorize the alternating sign, sometimes it can be confusing. Okay, but by placing the negative sign right away, you'll know that the negative is negative and the positive is positive. Okay, so 3 to the 5th, you have to simplify that. Okay, so that will be a number. So 3 raised to 5 is equal to 243. So plus, so this is, so you have to be careful when you simplify. This is negative 2 to the 1, that's negative 2, times 3 to the 4 times 5. Okay, so might as well grab a calculator when you simplify these numbers and type in directly. So times 3 to the 4 and then times the negative 2, and this should be minus 110. So I can replace the plus sign with the minus sign. So 810 x, so this is x to the 1, so x to the 1. Okay, and then this the third term, so this is negative 2 square, so that's 4 times 3 cubes 27, and then times 10. So 10 times 27 times 4, then that should give me a positive 1080, then that x raised to the 2. And then this, so you see the negative 2 raised to 3, that's negative 8 times 3 squared, that's 9, that's 72, times 10, 720, but this is negative 720, and the x is raised to the exponent 3. And then negative 2 to the 4, so you see the negative 2 here to the 4, that's 16, positive 16, times 3 is 48, and then times 5, you have positive 240, and then the x is raised to the 4. Then finally, that's 1 times negative 2x to the 5th. Negative 2 to the 5th is equal to negative 32. So you have 32 and then x to the 5. So this is the expansion of 3 minus 2x to the 5. Okay? Now, I would suggest that you use the Pascal's triangle when the exponent is still small. Okay? I consider 5 as a small number. Okay? Now, if you want to use a combination formula, you can use a combination formula, but you will find that more useful when you work on exponents higher than 10. Okay, so that's it. I hope you understand the two examples that I made, one with a positive sign and one with a minus sign. So we use Pascal's triangle to find the expansion, and then we use a pattern on the exponent, like the 3 will get the highest, and then it decreases until there's no more 3, and the negative 2x started with no negative 2x until you get negative 2x to the 5th. Okay, that's it.